Rootstock is a layer 2 EVM compatible blockchain that brings Ethereum style smart contracts to Bitcoin. What if you could test and interact with real contracts on Rootstock without any financial costs? Now, in this video, we take you from zero to hero in interacting with and forking the Rootstock chain. We'll begin by exploring the basics of forking and its intricacies, and then proceed to a more advanced case where we test and interact with a decentralized exchange contract through the forked Rootstock chain using Anvil and Hadapt. Let's dive in. Compared to Ethereum, building on Rootstock offers certain benefits, and some of these are low gas fees. Now, since Rootstock is an L2, which is a Bitcoin sidechain, transactions are executed for very, very low gas fees. RBTC, which is a Bitcoin pegged native token, it is the native token of the Rootstock chain. And since Rootstock is a Bitcoin sidechain, its native currency is pegged to the Bitcoin. This means that there is a more stable gas price. Also, Rootstock has low latency, and this translates in faster transaction speed. Transactions get executed because of its fast block finality. All these are the few to mention benefits that Rootstock has in store for developers building on Rootstock. And now when you're building on Rootstock, say building dApps or deploying smart contracts, knowing how to fork and interact with forks is a top tier skill to have. Unlike forking the other chains like Ethereum, when you fork Rootstock, there are also benefits that apply. Now we have Bitcoin peg liquidity. So since Rootstock, as I've said earlier, is a Bitcoin sidechain, forking Rootstock allows you to test Bitcoin-backed DeFi or DEXs with real RBTC balances and pools. Now, it also helps simulate Bitcoin layer 2 scenarios. So that means you can test Bitcoin DeFi lending protocols, treasury management, Bitcoin-based swaps and bridges. And all these are not provided by other blockchains. Also, it gives a realistic mainnet simulation with lower costs. Forking Rootstock lets you simulate mainnet condition for less, making it cost effective for development. And this, my friends, is why you should build on Rootstock. And also, when you're building on Rootstock, also learn to fork the Rootstock chain. All right, guys. So to explain the concept of blockchain forking, we're going to be using this image. And before I talk about blockchain forking, I believe that a number of people watching this video are developers or somewhat technical and would have come across the version control system Git and then GitHub. So there is this popular term on GitHub, which is forking. So let's say there's a person created a repository on GitHub and then is using some kind of software there. A person or a developer or whatever, you just want to like contribute to it or maybe tinker, play around with the software, you fork it to your GitHub profile. Whatever you do within that fork, whatever advancements, improvements, and everything you do within that fork doesn't in any way affect the original. And this is just how the blockchain forking works. So there is a blockchain, and forking, it means cloning. You are cloning that blockchain version at a particular time and a particular state. So it is being cloned down to your machine, and then whatever happens within that clone in your machine doesn't in any way affect the original blockchain. Now, from this diagram here, we see the Rootstock blockchain on the right, and then we see the local node on the left, and then the machine at the middle. So in the Rootstock blockchain, we see smart contracts like USDC, DAI, USDT, and then the swap router. And then there is an arrow which connects the machine to the local node, which is forking. And then in the local node, we see test addresses, we see test deploy contracts. So this is exactly what I've just explained. What is happening here is the process of forking is taking a snapshot of the blockchain at a particular time and at a particular state. That snapshot is then what the local node uses. That is simply how forking works. And now, how does a fork differ from a testnet, and how does it differ from a mainnet? Now, testnet and mainnet, you're basically the same thing. It's just that testnet is the test version, while the mainnet is the real thing. But now fork, a testnet can be forked and a mainnet can be forked. So forking is not only for mainnet or testnet, either of them can be forked. But then the mainnet and the testnet are very different from fork in that forking or a fork is just it's a clone version, a locally cloned version of an actual thing. Whatever happens within the fork stays within the fork. Like the moment you're done doing whatever you want to do with the fork, and then and you kill the fork, everything is gone. Like there is no trace that anything ever happened. But then that's different from a test net and the mainnet. A fork gives us a very interesting test environment, sort of like a lab, a lab, yeah, where you can just test out things as though they are real. But in the real sense, it's not real. It's a very funny concept, but then it's still very, very important. Still very, very important. So for testnets, we have Rootstock testnet. This is Rootstock testnet here. You can see Rootstock testnet here. It has an explorer. You can see transactions and everything. Similarly, we have the mainnet. So we can see how similar both of them are. Cool. So this is the mainnet. This is the testnet. Well, I mean, a fork doesn't have an explorer. It doesn't have all of this. A fork is simply what you run in your local node when you want to try out a number of things. Yeah. And let me emphasize this, that for forks, you do not need gas. It comes, you do not need, when you're interacting with smart contracts in a fork, you do not need to have actual gas. I love using forks a lot because, I mean, it gives us that the power to do so many things. Within a fork, you can impersonate another person on the blockchain. You can increase your ethers balance. You can increase your gas fee. You can just, the limits of what you do within a fork is just your imagination. That's why I called it a lab. You can do whatever you want to do within fork. And that is why developers use forks. They use forks to create. So when you're writing tests for smart contracts, there are cases where your smart contract rely on actually deployed smart contracts. So let's say you have a smart contract A, and then that smart contract, you have a smart contract A, and then that smart contract is depending on a smart contract B. But then this smart contract B has already been deployed on, let's say, testnets. Now, for you to actually test this contract A, you need to fork these testnets, a testnet where this contract was deployed on. Because by forking these testnets, by forking the testnets where B was deployed, it automatically takes a snapshot of B, also the smart contract B, such that with that fork, you can now test smart contracts A. I mean, forks are really, really helpful in cases like this because you don't want a scenario where you are just operating based on assumptions. Forking helps us really create that simulation where you can test things out. And this is really going to be an interesting ride for us. Okay, guys, before we start the process of forking, some background we need to lay really for this video, and we're going to be talking about the build besides here. If you haven't deployed a smart contract before, my advice to you is to go ahead and learn how to deploy a smart contract, learn how to write smart contracts. So this video, we're not going to write smart contract or deploy a smart contract. Our main goal is to pick a already deployed smart contract and then try to fork the blockchain and interact with that contract using scripts. So it's not so good when you're, you don't have any idea about Solidity or smart contracts, and then you're trying to do forking of blockchain. Now, a second thing is hard setup. So your hard setup should look like this. So what I'm using here is the Rootstock hard starter kit, and we can find that here. So let me just check Rootstock. Okay, I think this is it. So the link will be in the description. All you just need to do is clone this. Yes. And the next is Anvil. You need to install Anvil. I should have Anvil installed. I have Anvil installed, but if you don't have Anvil, so just head over to Foundry to install Foundry. There's a very, really good documentation for installing a Foundry. And when you install Foundry, Anvil is yeah, this is Anvil here. Anvil is the node. You use Anvil to start nodes, and it comes when you install Foundry. So this is the page which guides you on how to install it. What we just need from here is Anvil. Now, next on the list is Node.js. So just type node -hyphen version. And if you have it installed, it will show that. And if you don't, head over to node install Node.js. Yeah. So this is documentation that guides on how to install Node.js. So I think because I'm using a Linux, it's already by default selected Linux. You could, based on your device, is a Mac, you can select based on your operating system. And now last on the list is Rootstock testnet RPC URL. So the RPC simply stands for remote procedure call. And this URL is basically what we're going to use to make calls to the blockchain. And here I said either public or this. So the public RPC URLs, we can easily get that on chain lists. Chain lists, I hope I got that. Yeah, chain lists. All right. So we could get that from here. We'll just search Rootstock and then click on include testnets. So this is it, and select one of these that have a good score. So we could actually fork the mainnet or a testnet, but for tutorial purposes, we're going to use the testnets. So we're going to pick an already deployed smart contract, which is on the testnet, and then we're going to interact with it in the fork that we're going to make in our machine. Okay, so pick any of these that have a good score, and that could pass as the RPC URL. And if you are not satisfied with the behavior of the URL, you could go to alchemy.com, and then I already have an account, so I'll just sign in. So when you come here, you first need to create an app which is for your project. I already have an app created, so to save time, we're just gonna do this. I would select anyone here, and I will go to networks. I'll search for Rootstock, and boom, we have it here. So mainnet, testnets, and then you copy this. So this will also serve as an alternative to the public URL, because Alchemy is a node provider, node infrastructure provider. And then since it's not public, you'll have a better experience than using the public. All right. So these are the prerequisites for this video, and I can't wait to get started. Let's go. Okay, guys, to fork the Rootstock testnets chain, we're going to be using Anvil. And if at this point in the video you don't have Anvil installed, feel free to pause the video and go over to the Foundry documentation, which was shared in the last section, and the link is probably in the description. So ensure you have Foundry installed first, because Anvil comes with Foundry. Now, in Anvil -- version, you can see it's installed here. So we're going to go ahead. Now, Anvil -- help will show us variety of commands that Anvil comes with. Anvil is used to start a local node, and it's very super useful. Okay, so yeah, quite a number of commands, but we're more interested in forking configuration, and you can see the -- fork URL. You don't need to have it on your head, and you could just store it there when you could just check it out. All right, so to start a node, you could just use Anvil, right? Now, this starts just a random local node that doesn't even exist except from the context of the local node. So this is not forking any chain or whatever. It just creates a blockchain, a local node mimicking a blockchain. That's not what we're using. So in our case here, we're going to do Anvil -- then the fork URL flag, and then we're gonna need the chain list. We're gonna need the RPC URL to paste it, and then now this is how the forking works. By adding the flag, this local node now represents a snapshot of the Rootstock testnet. Now, from what we can see here, we can see some accounts here. These are dummy accounts that only exist within the context of fork. Remember, the fork is basically a sandbox, or like what I said earlier, a lab or a sandbox, where whatever you tweak and test and whatever configurations you do within doesn't affect the original. All right, so these are private keys. I mean, I'm so cool showing you the private keys because it doesn't exist outside this fork. You cannot try to steal this 10,000 ETH yet. All right. So what other things? Yeah, we can see chain ID, the ASU, the gas limit, and then the URL. Now this URL is basically the local host. So when we're going to be running our scripts here, like using npx add run, and whatever the script name is, -- network, we're going to reference local hosts, because local host points to this link here. All right, now we're going to go ahead into, so go into the Hadat project, create a script folder, and then I already created like an interaction file. So your name is interaction.ts. And now within the interaction file, we just have like some boilerplate code. This is basically like the main function. We use this to handle error, right? And I already imported it as here. And now this helper module, it's really like, it's like one of the most cool modules we're going to use. But then we're going to use that when we're interacting with deployed smart contracts already. Okay, now let's leave this commented part out. We're going to talk about that in the next session. Here, what I just did here was import signer. Now, all these signers here are basically these 10 accounts, 10 signers, and we can verify that by checking the balance. Okay, so we use the ethers.provider get balance method, and then we log the balance. And now, the reason why we have these two terminals open is because we're going to use this to be observing what is happening, because this node, this console gives us a picture of how a blockchain works. So while we're running our scripts here, npx add-ads, run scripts / interactions. Now when we run this, pay close attention to the left terminal. We're going to see some things happen now. And we can see it says listening to this, and then we see if accounts. Now, this is because of we did get signups. So it got an account, and then we can see Anvil metadata, and then the last was you get balance. And that's because of this provider.get balance. Okay, so by observing this, we get the feel of, how interacting with the blockchain from the roots feels like. And then here we're going to see the balance 10,008, which is basically the amount is. And if we should log the signer here, we're going to see is this address. Would log it. Let's just log it. Signer address. So let's just log this and we run the script. Okay, we can see that it's this. So when you're forking a blockchain, you do not need gas. You do not need to get gas. All that is happening within the fork or within that sandbox is mind-blowing. Like, you could literally do anything within this scope, and we're actually going to explore what we mean by that. Okay, so there are some issues that happen when dealing with forks. One of the issues is desynchronization. Okay, so simple meaning of synchronization in this case is when the chain that was being forked already changes states. Now remember, earlier I said when you fork a chain, it basically creates a snapshot of the blockchain at the particular time. So it snapshots the blockchain states at the particular time, and the states is composed of transactions, which are composed of amount of tokens, smart contracts, and everything. And let me paint a scenario here. So let's say where's my whiteboard, calendar? To explain this, we have the fork blockchain, and then we have the real blockchain, right? Now, at the point here, the fork, let's say person A had 10 USDC, right? So at this time, that was when the fork was made. But now there was a change here, and then person A has 0 USDC. And that's probably because of maybe the person had an exchange or used Uniswap or did whatever transaction. And now the blockchain was forked at this point where the person had just 10 USDC. And within your fork, you're trying to write an interaction script, which would be operating on the basis that person A has 10 USDC. But in the meantime, person now has 0 USDC. So when you're running your interaction script, you'll probably be getting errors. That's because the fork is no longer in sync with the real blockchain which was forked. Now, the simplest way to do this is kill the fork and rerun it. Now, this would simply take a new snapshot of the blockchain states at the particular time that you run the scripts. Now, this fixes the issue of desynchronization. Another issue that is faced is the low gas limit. And we can see here that the gas limit is 6,800,000. So the low gas issue can simply be fixed by there's a flag, you can add the gas limit. You could use this to increase the gas limit to 10 million, 10 billion, or whatever amount. And my friends, this is how to fork any blockchain with Anvil. And here we just forked Rootstock test. It's amazing, isn't it? All right, in the next section, we're going to interact with smart contracts. All right, so we're going to interact with smart contracts, deploy smart contracts in the fork. So if you can see here, okay, let's run the fork. Okay, so the fork has started already. It's currently running, and now we're not dealing with this anymore. Okay, so we want to interact with smart contracts, and now I'm going to explain this. So we have the contract address here, have the contract ABI, and then we get the contract here. Now the contract address before now I have going to select a smart contract on the Rootstock testnet, and this is the smart contract. I think it has some basic transactions. There's some transactions that has been run already. So I'll just select this and paste it here. And we're going to leave it to lowercase to avoid checksum problem. Okay, so let's look at the contract. So it's very basic, right? And for the ABI, now ABI is more called application binary interface, and it defines it defines the interface for the smart contracts. It's very useful in that, it has get contract at would create a contract object based on the contract address and then the ABI. So usually, most people would use the contract name, but here we are not the deployers of the contract. That means we didn't deploy the contract in this project. So we're going to use the ABI, the contract ABI, to build it. So if we had deployed the contract ourselves, I mean, we just put in the name of the contract, name of contract here. Well, we didn't, so would use the contract ABI instead. Right now, how do we get the ABI? We look at the contract and we could write it by hand, but that's not recommended. So we're using human readable ABI, so we could just copy this and make use of AI to generate it. So we could just paste this in and say generates the human readable ABI for this. All right, it's beautiful. It already generated this, but we're going to edit it. All right. So using AI, our codings, really codes improves, efficiency. All right. So we don't need the events. Yes. And what else? All right. I think we're good. If we were to write this by hand, we're going to be writing all this, just the function signatures here. All right, now that we have the ABI and then we've created the contract object here. Now this contract object would be what we're going to be calling the functions, invoking the functions on. Now let's look at the contract again and see the functions that are in the contract. All right, so we have mint dummy function, we have transfer, and it has balances and it has owner. Okay. So firstly, we're going to make read calls to see, okay, that this works. Now, when we're making this call, don't forget we're calling it on this fork. All right. So let's do const owner equals await contracts dot owner, right? And then we log it to the console. Console log owner. Okay. Now we're going to run this on the fork. So let's clear and then run it again. So we're going to look at what's happening. So on the right side, we see the owner and we see the owner's address. And then on the left side, we see a bunch of calls here, if accounts and the metadata, and then if call. Now, we didn't run this on the Rootstock network. When let's run the Rootstock network, we have done network dash RSK, test nets. But now we run this on the local host, which means right in our local host, we have already forked the Rootstock testnets, and then we are interacting with this. I mean, this is so cool. All right, so we see the owner's address to be this, and let's go ahead and do more fun stuff. All right, so let's go back to the contract, and we see that we also check balances, right? So let's check the balance of the owner, the contract. Okay, so we could do const owner balance, and as await contracts balances, and then we're passing the owner, and then we log owner balance. Okay, so we're gonna do if as format unit owner balance, and then 18 for the decimal. Let's run this and see what we get. And so we see that the owner has 0 tokens. Great. Now, if we go back to the contract, we see that for the mint dummy, it has an only owner function. And if we go to the only It has an only owner modifier rather. And if we go to the modifier, we see it enforces that the message of sender is owner. That means that this function can only be called by the owner. Let's note that down. Now, we are not the owner of the contract because the contract has been deployed by the contract has been deployed by someone else. But now we want to interact with that contract. We want to call the mint dummy function. We're going to do something called impersonation. And that is where the helpers come in. This helpers library helps us manipulate however we want within the blockchain. Sorry, not the blockchain, but the fork of the blockchain. So how do we use the helpers to impersonate? All right, so to impersonate a signer, all we simply do is we copy the address. Okay, so we're going to get rid of this. Okay, so we're still going to check the balance. So instead of awaiting this, let's put in the let's type this in. Now we already know that that address is the owner, right? Now we want to create an impersonated signer, right? So we can do it as a syntax. Okay, so we're gonna use this. So we're gonna say await helpers dot impersonate accounts, and we're impersonating the owner. And now again, we're going to create an impersonated signer based on this. So what this does, await helpers or impersonate accounts would sort of create an account within this fork where the address is. And then now this signer, impersonated signer, would make that impersonated account a signer such that we can now sign transactions using impersonated signer. Okay, so what we want to do now is we want to call the mint function. All right, so this would be balance, owner's balance before minting. This is really gonna be cool. Just follow me as I do this. So now we're checking the owner's balance before minting. Now remember, we are not the owner. I am not the owner. The owner deployed the contract, right? And now we want to impersonate the owner and sign a transaction. So we're gonna do await contract connect. Now we are connecting the impersonated signer. So the impersonated signer is going to be the one signing this transaction now. Then we're going to do dot mint dummy. Now the mint dummy function is going to accept two parameters. Let's check. It's going to accept the amount and address to address. So let's define amount to be ethers dot parse units, and we're going to say 118. Decimal is 18. And then the receiver is going to be a signer. All right. So the receiver is going to be signer dot address. Okay. Or do we mint? Let's see. All right. Let's mint to the owner. Let's mint to this owner, not the receiver. So we're going to pass in amount and then we're going to pass in owner. Right. Okay. So now let's check the balance of the owner again for this owner balance after, and then we paste. And we should expect that the owner's balance before and after should be different, and the amount after should increase. All right. So let's run this. Great. So we have owner's balance before minting is 0.0, but then something happened. Intrinsic gas too high. Okay, so we have to stop our fork and then add the gas limit flag and say this is 100 million. So the gas of the transaction is higher than the gas limits of the fork that we had. So we have to increase the gas limits of the fork. So we start this and then let's try and run this again. Good. So we have insufficient funds. So, and how do we fix insufficient funds for gas? Now, this is really, really interesting. We're trying to use an impersonated signer to sign a transaction, but that person that we're impersonating doesn't have gas to sign the transaction, right? So how do we ensure that that address has gas? To ensure that the address has gas, we're going to use something called helpers.setBalance. So just before we call this here, we're going to do helpers with helpers.setBalance. And then we're setting the balance of owner, or let's say impersonated signer. And then we're setting to add ethers dot ASCII panel. And then we're going to say 100, 1000. Now, this would set the balance of the signer to 1,000 ethers in gas that it would be able to sign this transaction. So let's call this again and let's see. Okay, the address is invalid. So we're going to change this to owner. Run this again. Okay, so we're going to change this. So it happens that where we're set, we're not supposed to use impersonated signer. We're supposed to use the address because this is an object. All right, so let's run this again and should work. Beautiful. So look on the left, you see the transaction, the gas used, block hash, the time and everything, just like how blockchain works. And now if you check, the owner's balance is 0 and then after minting is 100. Okay, that was a typo. It's supposed to be after minting. So let's run this transaction again. And now we should see that the owner's balance before should be 100. And now the owner's balance after should be 200. So let's run this again. Beautiful. So we can see that before is 100 and now 200. And the transaction states or updates correctly. This is really, really cool. I mean, I just impersonated someone's account on the blockchain, interacted with a function, and now, minted some tokens to that address. Forking blockchain is really, really cool. I mean, you get to test so many things, so many features, and the limit of what you can do is just your imagination, right? So we're going to interact with one more function, which is the transfer dummy function. And what we're going to just do here is we're going to send some amount to the to address. Okay, the to address here is going to be, so we're not minting anymore, but instead of minting now, we're going to do a transfer dummy. Or we could, let me copy this and comment this out. So now we're going to say owner's balance before transfer. And now we're going to do owner's balance after transfer. All right. So we're going to do this transfer dummy. And now the receiver should not be owner. The receiver should be signer. All right. Signer to address. Now, expecting now is that the owner's account should reduce from 200 to 100. And now the receiver should also increase. Usual balance should increase. Receiver balance after this should be, okay, so we're passing in signer dot address after, and we should also check before. Okay, so we have before and after, and we just we log it to the console. So receiver balance increased from this, which is okay, let's pass it using ethers. We're going to use this ethers dot format units, and as receiver balance before, and then 18, and then so the log format ethers dot format units, and receiver balance after. Okay. So want to show that it's the receiver balance increased from 0 to 100. Okay, so let's run this. Hopefully there are no errors. Okay, declare and then run. Beautiful. So we see owner's balance before transfer was 200, decreased to 100, and then the receiver's balance increased from 0 to 100. So we basically just impersonated someone and we used that person's account to do some things. All right, now here's the catch. Everything that happened here never existed. It happened within the sandbox. And let's queue this fork and then we clear this. We restart the fork and let's see what happens. Okay, now we've restarted the fork. Let's try to run. What we're going to do now is we check the receiver's balance and then we check the owner's balance. The last time we ran this, the owner's balance was 100 and the receiver's balance was 100. So let's do this. We are going to comment the transfer dummy out and then let's just log. Okay, so since there's no need to paste, so we're logging two things out, right? So I just want to do just one. So receiver's balance, just going to paste receiver's balance alone and then owner's balance. So there's no need for this anymore. And then this too, there's no need for this. Okay, so let's run this and let's see. Owner's balance is 0. Owner's balance is not defined up again. I will see that zero, we're back to where we started. The first time we created the ran the fork, before running any of the transactions, the owner's balance was zero, and so was the receiver's balance. But then after running those transactions, there were updates in the states. But now after killing the fork and restarting, we see that we're back to where we started. Why? Because whatever happened within the fork stays within the fork. The moment we kill the fork, every guys, like all the transactions and everything we ran dead, we have to restart again. And that is the beauty of, blockchain forking. It gives us the ability to do whatever we want to do within the sandbox. But whatever happens there never affects the real blockchain. And this is really cool. I mean, you could try out different interesting things. You could also go ahead to find an interesting smart contract to see on the Rootstock testnet and try to fork and play around with it. I mean, it's a really, really cool concept. And I'm super glad that we're able to, try out forking Rootstock testnet. On to the advanced part of the tutorial. So in the first part, what we did was, basic. We dealt with the token, dummy token, and we deployed it and forked, interacted with the contract. Now in this part of the video, we're going to fork the Rootstock mainnet. And while we're going to do that is we want to deploy this decentralized exchange contract called GojoDex. We're going to deploy it on the fork. And our goal is to test, interact with this DEX contracts as the add token pair with deposits, then the swap. We want to utilize the liquidity on the mainnet, like the tokens that are available there. We're going to impersonate signers and make use of, the valuable liquidity there to test the functionality of this smart contracts. I can't wait to jump on this right now, guys. So that's what we're going to do in this part of the video. So this is the smart contract has been pre-written for now. Our focus here is the add pair with deposits. So this function, the owner will be able to, tokens in pairs. And within this function, there is a transfer from here. So it's sort of like adding liquidity to the decentralized exchange smart contract. So this function is basically what does the adding of liquidity. Now, the swap function is the function that would enable user, basically anybody, be able to, take a particular token and swap it to another. And as we can see here, it uses the calculate to amount, and that calculate to amount makes use of the pair. All right, it uses the pair. That means we need to first create the pair before we'll be able to swap. That's basically how decentralized exchanges work. So there are people that add liquidity to the liquidity pool, and then because of the liquidity they have added, we are now able to make swaps from one token to another. All right, so let's get started. First thing, you need to write your deploy scripts, and yeah, we're still using the Rootstock Hard starter kits. So just write the deploy script and we're good to go. So within our script folder, there's a basic setup here. We have the helpers to help impersonate and do all that crazy stuff. We have the contract address. So when we deploy the DEX on the fork, we're going to get the contract address, and we have the contract object. We also have ERC20 ABI. Now, if you look at the decentralized exchange, we notice that the tokens here are ERC20 based. So that is a focus. We're focusing on ERC20 smart contracts. That's the ERC20 tokens. Okay, now before we proceed, let's first spin up our command prompts, and yeah. So I already have the command here we're going to use to start the node. To get Rootstock RPC, you can go to chain lists, and then this is Rootstock already here. Just copy one of these RPC links. Okay, so let's start the node. All right, cool. The node has started already, and now we can go back. Yeah. So what we do next is we're going to deploy the contract npx hard deploy, and now we're going to deploy to localhost. Then the tag is the tag I gave here. So inside the deploy dex, okay, dex, that's the tag dex. All right, cool. So it's been deployed here. We copy the contract address, and paste it in here. The scripts, paste it in here. Next thing to do is we observe the smart contracts, the DEX smart contracts. We need 2 tokens, right? So we go to the Explorer because we are forking Rootstock Mainnet. So we go to Rootstock Mainnet. We go to Rootstock Mainnet. So beforehand, I found 2 contracts that we can use, which is the RIF. RIF is an ERC20 token, and it stands for RSK Infrastructure Framework. Now, if you want to search for tokens, you can click here and then click the token start. So you will see all that kind of token. Well, I selected this already. And then the second token I selected was the SOV, Sovereign. So these are the 2 tokens I selected. I'll just copy contract addresses and paste them. So we're going to say const RIF contract address, and that's going to be this to lower case. And then the same thing for SOV, that should be all caps. So we copy the address and paste here. Great. Now the next thing to do is we create the contract object just like what we did here. Now we create for both of them. Okay. We call this RIF and then SOV. Now instead of this, we're going to use the ABI, ERC20 ABI, because they are both ERC20 smart contracts. Now the next thing to do is, since we want to utilize the liquidity on the mainnet, we need to find accounts on the mainnet that have huge supply on the RIF and then the SOV tokens. So we just go here, we go back to the Explorer. Now we can see holders, 19,000 holders. So you can click on the holders tab here, and then you should be able to see all the holders. I mean, the Explorer gives like better presentation. So from here, we can observe that each address have so percentage, and I think we need the person with the highest. So we're not going to pick any contract like there's a smart contract. Any account that is a smart contract, just avoid. Like we can pick this one, we can pick anyone here. And then the first holder here, that works too. So you can see that holder has 5%. That'll be the holder for the RIF. Okay, so we say const RIF holder. My bad. Const RIF holder, and that's this. Then we also do to lowercase here. The same thing for the. So we're gonna do the same for the SOV holder to lowercase. Now on the SOV parts, you can see the holder. The first holder is a proxy contract, so we don't go with that, but we can go with the second. Great. So we paste that in here, and then we're good to go. Now, to test that our fork is working properly, we can check balance of both of them. Now, from the Explorer, we can see that the balance of this address is 13 million, about 13.8 million of the token. And for this year is 226 million. So we're just going to, use the ERC20 contract objects that we have for each of them. And then we're going to get the balance. So RIF balance, away, RIF contract dots. Now, since it's an ERC, we have balance of. So we do balance of. And then we're checking the balance of the RIF holder. Then we do the same for SOV contracts, dot balance of SOV holder. Now we are going to log it to the console. RF holder has, I can do ethers dot format units, the RIF balance, and then 18. Then we also log this. It should be SOV holder has SOV balance. Okay, now we run this to see if our fork works properly. Okay, so we're going to do mpx that runs script is dex. Let's see dex slash network local. So we have an error. The error is here. We didn't replace the contract address properly. So that's the error. We will run this. Beautiful. Now we can see the balances, and these tally with what we have here. Now this is enough proof that the fork of the rootstock mainnet in our local is working perfectly. So we move on. The next thing we do is Now that we have affirmed that these guys have real, liquidity, we're going to impersonate them. So we can just comment out the balance here. Oops, we're still going to need it later. Then you impersonate the signers. Now, do helpers, impersonate accounts, RIF folder. Then we create a signer just like we did previously. Impersonate, personated RIF folder. We'll do the same for the SOV holder. Cool. Now we have been able to impersonate both. The next thing to do is to send some amount of each token to the owner of the contract. Because if we check, let's check the owner of the DEX contract. So let's say owner equals DEX contracts. So DEX contracts dot owner. If we log this, run this, okay, forgot the await. Now this address would be the only one that is able to call this R token pair because we can see the only owner modifier. But then anybody can call the swap. So what we want to do is want to take those addresses, like as we've impersonated them here, we're going to send tokens to this owner who is the same as the signer here. All right. Now, when we send tokens here, we're now going to use the owner to add liquidity using this function. Now, let's do that. So we're going to send RIF and SOV to the DEX owner. And how do we do that? So we set RIF amount. It has dot pass units. And let's say about 1 million to 18. Let's make it 2 million because the addresses that we picked have quite a number of tokens. So we can say pass units. This should also be about 1 million. Cool. So let's check the addresses to see. All right. Now we're going to send. We're going to do await RIF contracts dot connect. We're going to connect the impersonated RIF folder, then dot transfer, and then transferring to the signer address RIF amounts. This has to be inside the brackets. You do the same for the SOV contract to be impersonated SOV holder and SOV amount. Now, if you check the balance of the owner, say RIF contract dot balance of, we're gonna do balance of signer address. We're gonna do the same for SOV. Log, then log contract owner has format units balance. Then we'll do the same for SOV. All right, cool. Let's test this out. Okay, we have an error. All right, and very well. Oh, insufficient gas. When impersonating, we would add this line would set the gas amount that each of them would have. So we just say owner at the ethers or car ether. Now, since this is Woodstock mainnet, what we are setting here is actually RBTC. But since we're using JS, it refers to the native token of any chain as ether. So when we do pass ether, referring to like the native token here, which is actually RBTC. So this is referring to 10 RBTs. Okay, we do the same for SOZ holder. So I believe that guy should be enough. Let's run this. Great. Now the contract owner has 4 million of them stage. But what we expect is 2 million, 1 million. Okay, we can let's check this properly. Okay, that was from here. I'm supposed to do SOV contract. Already getting the balance. So we comment out the parser we're transferring. So let's be sure that everything works according to blind there. Great. So we have 1 million. This will be run twice. So we can kill this and then delete. If we want to rerun the fork, we have to like delete this deployment, avoid errors. So basically we can start this again. Be sure we're on safe side. Now the fork has started again. We deploy smart contract. So I don't think the address change is same. We run the script
run the space and ensure that everything works well.
Okay, let's check the balance of the owner at first. The owner has 0 at first. Now let's
comment this part back. We rerun the script. Now everything tallies. Perhaps 2 million, I have 1 million there.
Everything tallies. Probably the first time we ran the script and it failed. I'd already sent that unpad token already. Okay, now we can run this multiple times as much as we want. Now, if we comment this part
out, let's comment everything out here. And then if we check the balance of those holders,
we're going to see the balance have decreased. We check properly, we'll notice that there's a decrease. Let's rerun this again. Rerun this, but now we're going to make it, let's see, use the same thing, but I'll edit this also see properly. Okay, uncomment this. So we see 222 I there, but now the owner of the DEX contracts
now has both RIF and then the SOV token.
The next thing to do is interact with the R token pair with deposit function. And we can simply do that now. So the first thing we're going to do first is we would set approval for the DEX, because within this contracts, within this function, the transfer from ERC2 should transfer from for both of them. So we're going to set approval on the RIF and the SOV paper. So we can simply do that by RIF approve. And now we're approving the DEX contracts for, let's approve the whole balance. We can just say about 2 million. The balance is like the balance. Okay. I think 2 million is enough. Or let's say 200,000. 200,000 for the SOV contract, and say 800,000. That's because we want to transfer 200 and 800,000 of each of them to DEX contracts.
Okay, now let's add the token pair, taking the liquidity. Now we're gonna do await contracts dot add token pair.
And let's copy from here. We can see that the function requires the address of the two tokens, so we can pass that in here. RIF contracts and then SOV contract address. And the next thing is the rates. Now the rates depends on the amount that we are passing in. So for the RIF, let's go to Escalibur. For the RIF, we're passing in 200,000 RIF. For the SOV, we're passing in 800. And if we do the ratio, one RIF is going to be 4 SOV, and one SOV is going to be 0.25 RIF. So the rates here, the rates that we're expecting here, the rates A to D would be 4, and the rates B to A be 0.25.
We're going to do, because of pass units, is say 4, then 18.
And then the next rate be 0.25. Whereas in pass units, because we want to avoid, the underflow, to basically convert this 4 to a B. Next thing to pass would be amount. So we're going to say the amount was what we did here. We already approved the amount, so we can just copy and paste that in. And then this should work, right? This should work. How do we know it will work, right? So what we can do is, before we won't do any of all this, we can try to see if we swap, right? If we swap, would it work? So let's say we want to swap RIF to SOV. Okay, one swap RIF to SOV. Set the swap amount to 1,000. Let's say this is 8,000. 10 units. Now we also set approval. We can just copy dates down here. Okay, and now we are approving swap amount instead. Swap amount. Now if we check the swap function, the transfer from only happens from the from token, which is the RIF. We're transferring from RIF. We're swapping from RIF to SOV. So we can only do approval for the RIF. Now, after approving, we now call the swap await DEX contracts
swap, then RIF contract address, SOV contract address, and then the swap amount. So this is basically swap 1000 RIF to a particular amount of SOZ. What we're going to do next is we're going to check the balance. So we uncomment this because we want to check the balance before swap. And then we also want to check the balance after swap. So we just copy all of that and paste all of that in here. This, the after swap, the swap, after swap. Good. Let's try to run this and observe. So we can see that on these parts, you see token pair does not exist. So the contract transaction was reverted. And then here we can see that nothing basically happens. So the owners, the contract owner balance is the same. And yeah, basically it's just same. So now, when we're doing the swap, we're still using the owner. Well, it's not necessary, right? We could impersonate another signer to do that, but I mean, just for everything is just flow in one direction, right? So let's continue. Now we see that the token pair does not exist here because we have not added the token pair here with deposit. So let's try to do that by uncommenting this here, which was what we wanted to do earlier. And now if we uncomment this and if this should work properly, the swap should work properly. So let's try to run that again. Great. So we can see that everything worked properly. So we had 6 million here and we had 3 million. Now let's do the math, right? For adding liquidity, added 200,000 and 800,000. That'll be 6 million minus 200,000. That'll be 5.8 million. And then this would be 3 million minus 800. That would be 2.2 million. Now from the 0.8 million here, we swap 1,000 of it. And that gave us 4,000 of this. Okay, so we can, instead of using the signer, we can just connect. We can connect, let's say dot connect, can connect this RIF folder. We can connect the RIF folder. And now we are free to comment this out. And what else we have to comment? We can comment this out also, but we don't need any approval anymore. Don't even need imbalance. Comment this out. But if people comment that, let's complement this, then I think we should turn this to a let. Yeah. Sorry. What we want to do is once you use this signer that we impersonated in the first place, want to swap 10,000, 18. So we're going to check the balance before. You say before swap. Now after swap would be this. After swap, okay, we'll comment this out. So after swap, the RIF owner has this. Okay, no. We're supposed to check. This is tricky. So we want to check the SOP balance of a holder. So that means we're basically going season. Let's look at this properly. Now we're also going to check for this person. When you say before swap RIF folder. So we're checking both the RIF balance and the SOV balance for that impersonated signer. And now when we come down here after the swap, we're also going to check. I'm not checking for the signer now. I'm checking for RIF folder. And this should be RIF folder. SOV balance. Let's see. Yeah, this should be a let, not a close. But I wanted us to check out, a different signer. Instead of using the same signer who added liquidity, we can use a different signer. So that's kind of like simulate difference. So people playing different roles. So, different set of people add liquidity to the decentralized exchange. Different set of people are performing swaps. Now, I expect this to work. Okay, after swap, RF balance. After swap, SOV owner balance. Okay, let's trust this works. All right, let's run this. Okay, so it says here, before swap, RF has this. Before swap, has this. Now, after swap, he has this, and after swap, he has this. So basically nothing happened. This balance remained unchanged, right? Let's look at it properly. It remained unchanged. Let's go and check why. Okay, I can see why. That's because it failed. The swap failed. You can see reverse. It failed because the approval was not done properly. This approval is supposed to connect So we're supposed to connect the holder that, and this should work as it has RIS as SOD. Okay, so let's say, effect this out to see again. Beautiful. So we see that the balance reduced here to this, and then the SOV balance increased from 0 to 40,000. And that's because of the liquidity that has been added by the owner of the centralized exchange. And I feel like this is not so complex, though, a bit advanced from what we did earlier with the dummy tokens. Now you're free to test out different things here, like the withdraw. This is basically the owner can withdraw the whole funds from the DEX, and other. But the little time we had here, we're able to add liquidity to the centralized exchange and also make swaps using different addresses. Right now, since we've been able to test these DEX and see that it works properly, and the reason why we had to use the stop mainnet fork was because we want to see how the contract which we're going to deploy at the end of the day, how it's going to be held, and yield liquidity to be added. And that is the design for forking. We successfully run it, and congratulations on that.
Yo guys, so it's been a jolly ride, starting from the beginning part of the video where we started from the basics of forking, understanding forking. Then we used a dummy contract, a very simple contract, as a case study. We deployed it, we interacted with it in, a fork of the Rootstock testnets. Now we went on, to an advanced case where we didn't actually deploy though. We had a decentralized exchange contract, and now we forked Rootstock mainnet because we want to deploy the DEX on the Rootstock mainnet fork. And then we used real liquidity, which are like the RIF and the SOV tokens, impersonated people that had those tokens on the mainnet, and then used it to test how our decentralized exchange works. Isn't that beautiful? Like being able to see how that works in real time. We didn't even have to use any gas. We automatically set our BTC gas via, our scripting. This is really nice. I mean, from here, we can go on to now deploy our decentralized exchange smart contracts because we already have the confidence of how the smart contract works, even in the real mainnet environment. Congratulations, guys. And I hope this was really helpful. Want to take it further? Explore Rootstock's documentation to start building your own projects. Also, you can dive into the developer resources for hands-on support. And then feel free to join the Rootstock community to connect with other builders and opportunities that the Rootstock community offers. Links are in the description. Happy coding.